In this lecture, we will going over to electron affinity. As far as the definition goes, electron affinity is the energy associated with the addition of an extra electron to the outermost cell of an atom. We have A gas and we are adding an electron to it to form A minus gas. Now the energy associated with the addition of this one electron to A gas is called the electron gain enthalpy. Now it can be positive and negative both depending on the way it behaves while addition of an electron. If A gas loves to receive an electron, then it would said to have a positive electron affinity and therefore a negative electron gain enthalpy. That means it would release energy while the addition of an extra electron to it. Now we have A gas, A minus gas and A2 gas. This we have formed by the addition of one electron to the subsequent preceding atom. Now when we look into the addition of one electron to A minus gas, we see that we are adding an electron which has got a negative charge to an atom which has also got a negative charge. Therefore we will see some like repels like kind of thing, and therefore the electron gain enthalpy associated with this, that is EA2, will always be negative. On the other hand, if we see that while adding the electron to A gas, we are adding the electron to an atom which is neutral, therefore EA1 may be positive or negative depending on the atom. From the experiment, it has been found that EA1 plus EA2 is always 0, always less than 0, and this is supported by the equation here, that is conversion of O gas into O gas 2 minus. We have seen that EA1 plus EA2, the sum of EA1 and EA2 is negative, that is this reaction is endothermic. Now another observation is that the second period element of P block is having less electron affinity than its subsequent than its corresponding third period element. For example, the boron is having less electron affinity than aluminum, and same goes with the remaining elements. Let us see the reason behind it. Let us compare F and Cl. So as far as the size comparison of size goes, we know that F has got second cell and up to second cell, and B and Cl has got up to third cell. Therefore obviously the size of F would be less than Cl. Therefore having a smaller size, it would have a larger electron density around it, okay, and therefore the repulsion between the two electrons would be greater, okay. And now when an extra electron wants to add to this, then we see that since it has a higher electron density fluorine, therefore addition of this extra electron would be difficult, okay, and therefore the electron affinity of fluorine would be less than that of chlorine. And a similar explanation can be given for the other second period elements, okay. Now let us see the formation of Cl2 gas by two gaseous Cl atoms. Here the point to be noted is that we would always get Cl gaseous, not Cl solid. The reason is that to get Cl to solid, we need to the addition of Cl plus and Cl minus ion, which is you can say difficult, because we can get Cl minus ion, it's okay, but getting Cl plus ion is really difficult because Cl atom is a non-metal and it would have a higher Z effective. Z effective is basically the attraction on its outermost electron, and since Cl has got a stronger hold on its outer electron, therefore it would be difficult to knock down an electron from the outermost cell of Cl atom. Therefore it would have a higher ionization energy. Therefore formation of Cl plus gas is really difficult. Let us see what happens when we add one electron to A gas. It forms A minus gas, and removing an electron from A gas, we get A plus gas. Now we know that energy associated with this would be called ionization energy of A, and addition of electron to A gas to form A minus gas would be called electron affinity of A, and removing an electron from A minus gas to form A gas would be called ionization energy of A. By conservation of energy, we say that EA of A would be equal to IE of A minus, okay, which is written here. Now we know that it would be easier to remove an electron from A minus gas to form a neutral atom A gas, while it would be difficult to add an electron to A gas to remove an electron from A gas to form A plus gas. Therefore ionization energy of A minus, that means this, would be less than that of A gas. So, A gas, that means this. Now we have already equated ionization energy of A minus to electron affinity of A. Therefore we can write that electron affinity of A is less than ionization energy of A. So this brings us to the end of this lecture. In next lecture we will go on to lattice energy.